So if we are going to take this one as a so here carefully we have to observe it. Small correction is required. So common data. So problem is a radionuclide A with decay constant E1 transform into A2. Decay constant is A2. Okay, a radionuclide A with a decay constant E1. So this mostly I can write it as a A1. So a radionuclide A1 with a decay constant E1 transform into nuclide A2 with a decay constant E2. Assume that the initial moment of the preparation contains only the radionuclide A1. So initial moment only A1 is there. Later it is transformed into A2 by having decay constant E1. Later it is also decaying with a constant of E2 is saying. So we have to find out that disintegration total number of nuclei N2 we have to find out. So we are finding the value of N2. So for the purpose first this is disintegration. So this the number of nuclei are dN1 by dt is equals to minus lambda 1 N1. The same thing we are doing here, dN2 by dt is equals to means second nuclei when it is disintegrated starting disintegration, that is going to disintegrate like this, dN2 by dt number of nuclei which is disintegrating A2 number of nuclei are disintegrating, that is so dN2 by dt is equals to minus lambda 2 N2 plus lambda 1 N1. So N1 is equals to already, but we know formula is a famous formula, that is N1 is equals to 810 e power of minus lambda 1 t. So this value if I write as it is dN2 by dt as it is I have written, and the same term but plus I have written first and minus I have written, that's what I have done lambda 1 N1 plus, that's fine, first I am writing minus lambda 2 N2 minus is that, so minus I am writing next. So now what we are doing is carefully if you observe it, we know N1 is equal to what, N10 e power of minus lambda 1 t. So this value in the place of N1 here I am substituting, in this one N1 place I am substituting this value. So dN2 by dt as it is I have written, lambda 1 as it is, but in the place of N1 what is that, N10, so N10 e power of minus lambda 1 t e power of minus lambda 1 t minus lambda 2 as it is, N2 as it is we have done. So only the thing is in the place of N1 we have substituted this value, that value we can see it here. So multiplying both sides with e power of plus lambda 2 t. So if I multiply both sides, what happen, e power of plus lambda 2 t into dN2 by dt as it is, next lambda 1 N10 e power of minus lambda 1 t, the power of minus lambda 1 t into, we are multiplying this value here I am writing, so this term also e power of plus lambda 2 t minus lambda 2 N2 as it is, this is multiplied 1, that's why e power of my plus lambda 2 t we are getting. So what we are writing is here, if you want to write here this term minus lambda 2 N2 e power of plus lambda 2 t, if you write that side e power of plus lambda 2 t dN2 by dt as it is, this term I am writing bringing to this side of the equal to, so if it becomes this side, if it comes to this side it becomes plus lambda 2 N2 e power of plus lambda 2 t is equals to lambda 1 as it is, N10 as it is, e power of lambda 1 t e power of lambda 2 t. So here minus lambda 1 t, here lambda 2 t. T is a common if I write, if not okay you can write, I write like that also, e power of minus lambda 1 t as a plus lambda 2 t. So now what I am writing is, it is differentiation, just like it is differentiation of N2 and e power of lambda 2 t, like that it is there. That is why this I am writing as a differentiation of d by dt of N2 e power of plus lambda 2t like that is writing u into method. U is n2, v is like this. If I can write like this, d of uv, like that. It is a u, it is a v, n2 is a v, like that if I write. If not, n2 is a u or this is a v, if I write d by dt of what, n2 e power of lambda 2t. Is this all we are writing like this as a differentiation formula. So lambda 1 n1 0 e power of lambda 2 is tt, lambda 2t is a plus 1 is a sort, first I am writing here. Next here minus lambda 1t is a, that's I am writing next second. So minus lambda 1t. So now in this equation if I integrate, what happens, this is not integrable value, e power of lambda 2t. So e power of lambda 2 as 2t, and dn2 is integral value, so n2 is integral value, so dn2 I can write. So integration value limits n2 0 to n2, because starting from n2 0 to n2 values it is happening. So starting time number of nucleus are n2 only, later maximum number becomes n2. So minimum to maximum number of secondary nucleus a2. So secondary nucleus number n2. So that is value. So n2 dn2 e power of plus lambda 2t, e power of plus lambda 2t over is equals to lambda 1 n1 0 e power of lambda, here t if I take common, lambda 2 minus lambda 1, lambda 2 minus 1, t is common taken. So here into this is a, this cross multiplication integration if you do it d to dt, so dt is happening. So next what is happening here, carefully observe it, e power of plus lambda 2t is there. So e power of plus lambda 2t, so dn2 is the integration value. So it is not an integrable value. If I remove it outside and if I integrate, what happens here, I can write n2 0 to n2. So minimum limits to maximum limits if I apply after integrating n2, I can get it. So here I can write here. So this is not integrable value, so we are writing outside, and integration of n2 0 to n2, dn2 is equals to n2 integration value. So this is limits we have to apply n2 0 to n2 as it is you are writing is equals to this integration value, lambda 1 already it is there, it is not integrable 1, it is also not integrable 1, so I am writing outside n1 0. This integration 0 to t e power of lambda 2 minus lambda 1 into t into dt, integration is what, e power of lambda 2 minus lambda 1 into t lambda 2 minus lambda 1. So this is a value for integration. So here limits we can apply only for this term, that's why I am writing in the separately in the bracket. So 0 to t limits I have written. Next, e power of plus lambda 2t n2 minus n2 0, higher limit n2, lower limit n2 0 you have written is equals to lambda 1 by lambda 2 minus lambda 1 n1 0 as it is. So here what limits if I apply limits t is equal to t only, then we are getting as it is, but t is equal to 0 if I apply it, e power 0 becomes 0 means what, 1. So minus, it is lower limit, so minus 1 we are getting. So n2 minus n2 0, this form is this I am sending this side as a denominator of n1 0. Then if I bring it here as a denominator of this one, so n2 minus n2 0 as it is, lambda 1 lambda 2 minus lambda 1 over n1 0 e power of lambda 2 minus lambda 1 into t minus 1 by what happens, this term we brought as denominator e power of lambda 2t. Now n2 minus n2 0 is equals to what happens, lambda 1 lambda 2 minus lambda 1 lambda 2 minus lambda 1 n1 0 e power of minus lambda 2t plus lambda 2t gets cancelled, this term and this one gets cancelled, and minus lambda 1t remains. So e power of minus lambda 1t only remains, minus e power of this, if it goes up, minus e power of minus of lambda 2t we are getting if it goes up as a numerator. Next, if what happens if n2 is equal to 0, if n2 is equal to 0, if I substitute here, means this integration is not yet started, maximum value reaching up to n2 only. So if I write there, n2 is equals to lambda 1 by lambda 2 minus lambda 1 lambda by lambda 1 lambda 2 minus lambda 1 and n1 0 e power of minus lambda 1t minus e power of minus lambda 2t as it is we are writing. So this is a final value of total number of maximum number of N2 nucleus when it is transformed into A2 nucleus. So A2 nucleus becoming A2 nucleus, maximum number A2 nucleus or N2 number, that N2 is equal, this is the value finally we got.